So we have this closed system, and we have these three heights. So the conservation of energy bar graph project. Okay, so we're going to find the potential energy at H1. That's our first step. So at H1, and then first set is 15. So at H1 equals 15, and these are all going to be meters, even though I didn't say meters for everything. It's all meters. So what do? So potential energy is mgh, mass times gravity times height. And that is going to be our maximum potential energy because that's the maximum height. But you don't have to put this, but it is what it is, maximum potential energy. Yep, that was also my bad on that. So let me just put in the mass that I'd like you to use. Just a small object, let's say 2 kilograms, all right? So mass is 2 kilograms. All right, and that's going to be for all of your sets. 2 kilograms. Gravity is gravity, 9.8 meters per second squared on the Earth. And then 15 meters. Okay, so that's going to be our first potential energy. Calculator out. $294 joules. And that's what you have there. And then we know that it's at rest. So the kinetic energy at that point is 0. And then therefore the total mechanical energy is just going to be the sum. PE plus KE equals ME. So therefore we have 294 joules plus 0, 294 joules. So like I said, the mechanical energy that you have here, 294, is going to be the same amount, is going to be the same for all of the heights. You're going to have 294 joules of mechanical energy at 15 meters, 7 meters, and 0. So that's going to always be constant, and it helps you get the corresponding potential and kinetic energies. So let's go now to step 2. Find the potential energy at H2. Seven meters. So mgh, I'm just going to say 2 and times 7. So 19.6, 2 times 9.8 times 7, 137.2 joules. Okay, so now PE plus KE equals ME. You know that ME is 294. So we have 137.2. See how easy that is? You can find the kinetic energy in the air. It's going to be a percentage, a fraction of the total, and relative to the potential energy, it's going to be a fraction of it, whole thing. So 137, so KE, 294 minus 137.2. Is 156.8. Since 7 is slightly less than half of the total amount, you're actually going to have more potential energy after the halfway point. So this halfway point is 7.5. Anything less than that, the energy is going to increase in the kinetic band, if you will. It's going to becoming, the energy is going to become more and more kinetic and less and less potential, such that at the end, all of the mechanical energy will be kinetic energy because the height will be 0. So that's some kind of logic to keep in mind if you want. Just take it as face value. So these are our amounts here. So the total, and again, add them, and it's going to be 294. All right. So that's the second step. So obviously, the third one is easy. When there's no height, there's no potential. So MGH, H3 is 0. 0 times anything 0. We know that the mechanical energy is 294. Therefore, kinetic energy is 294. 0 plus 294, 294. And you're going to do that for all the other 9 sets. Any questions thus far? And take that out of here. So 0 plus, well, even if you didn't make that inference, this can only be 294. All right. So now we've got our calculations that we can make this the similar picture on page 258 with the bar graphs. And try to get colorful, I guess, 3 colors. But if you don't have any other colored pens or something, it's all right. Just do 1 color. So here's our calculations. And now let's go and create our bar graph. Okay, so I'm trying to squeeze this in here. Yeah, I guess so. Let me see. All right, the ground. So we know that the first height is 15, 7, 0. You don't have to say 0 meters. You can just put 0, but 0. Of course, your paper is going to be larger and all that. So let's say GPE, gravitational potential energy. So technically, the PE is GPE, gravitational potential energy, because we know that there's another type of potential called spring potential energy. We saw that last time. So let's just mark these guys in: GPE, KE, and ME. Let's see, I might run out of space here, but you can expand yours. So the first guy, let me see, I'm just gonna use red here. $294 joules plus nada. 0. It's at rest equals energy saved. Total energy always saved, 294. I hope you get the gist of it. That's equal sign. You guys see that? Questions? Pretty all right. And that corresponds to the ball being at rest. You can say at rest, or anything, any kind of markers to get you going. I'm gonna have to just squeeze this guy in. Your paper would be large. I kind of like the limitation of that right now. Yeah. Okay, so I'm just gonna put PE. And I scroll down here, right? The 137. So you can approximate. So you know that 294 is always going to be the same height, reflective of the energy being saved. And blue here. If I do red, see, kinetic energy starting to take over, and it's going to become all kinetic at the bottom. Right, and you put your numbers in there. 137.2, 156.8. Yeah. And 294. The same thing over here. Right here. So PE or of course for you it'll be expanded out. Just limited at the moment here. 0. Put a plus and it equals plus equals right. So you don't do that for all the sets. Energy stays the same, just changes form. It's another way of seeing that. By calculations, by the graphs. I mean, if we have time, I did something last year called LOL diagrams. You'll know what I mean when you get to it. Like the shape of the graphs are an LOL. Yeah, see, have to see it to believe it. It's supposed to be funny. Okay, so here, the speed is the maximum. Therefore, kinetic energy is max. So there's just total kinetic energy. You can do, it is a V here, but it's not maximum. It's moving, but it's still in the air. See, so that's why it's both, right? Give you appreciation for that. And here, V equals 0. So all potential energy, and kinetic energy is 0. So bar graphs reflecting the physics, what's going on. Questions? And you're going to do that for the other 9 sets. This is due today at 5 o'clock. I'll give you time now to work on as much as you can. Before that, you can kind of, now after you do that, you can get an appreciation for these figures. Like this one roller coaster figure that you see on page 260, where at the maximum height, the energy is all potential energy, and then it starts to cascade. So we're starting to go below the maximum height. Once we start to go below maximum height, as we do here, the energy slowly becomes kinetic, or you now have motion, the energy associated with motion. So below the maximum height, but still in the air, some of the energy becomes kinetic energy, even though some is still potential, as we see here in the second bar graph set. But once we hit the ground, so like in the roller coaster figure here, if you're looking at that, I'm just pointing that out to you. Page 260, at the lowest, at height equals 0, the lowest point, all of the energy at C is kinetic energy, like we see here in our bar graph. So you can also, if you want, you can say at this point, PE max, KE 0. Don't have to do that. Just kind of, keep in mind and give you more appreciation from the body that you understand what's happening here. It's maximum because it's maximum height and it's at rest, so KE is 0. And then at the very bottom, KE is maximum, P is 0. I can write that out better. Because now it's hitting the ground at maximum speed, so it has maximum kinetic energy. No height, so potential energy is 0. But the total amount of energy, no matter where you are in this system, will be conserved, will be the same. 294, no matter where you are, 294, between these 2 points, between 15 and 0, 294, 294, 294 total. But the energies, the amounts between PE and KE change. But the sum never changes. When we're in a closed system, we are closing it from friction. If we allow friction, which is in the real world, then things change. Our kinetic, our conservation of energy equation is going to become equal to the energy due to friction. And it gets a little complicated, slightly. Are there any questions before I break you out to your rooms?
Are we using 2 kilograms mass for all of them?
Yes, 2 kilogram mass for all.
And because we just did number 1, do we have to include that in our finished part, like when we turn it in?
Yes. Besides, did number 1 for you, and you want to include that.
Okay, thank you.
Yep. So you have sets 2 through 10. You work efficiently. You could get it done today, but you have until 5 to complete that. All right.